that work for everybody? Should I make it full screen? There we go. Cool. So it's very exciting to actually be here. I've already met a lot of cool speakers and people that have had the pleasure of talking about all sort of things. So for today, I think that we can sort of start. You can do this if you want, but you don't have to. I'll just be talking through it. But if you scan one of these QR codes, if you have a laptop, on the left, you can download the GitHub repo. And on the right, there's actually a web app that my brother, who was a speaker here last year, actually was kind enough to prepare for us. So that's going to be an online server where you can sort of play with the models that we're going to be talking about today. And if one of them doesn't work, you can try on the other one by just adding a 2 at the end. GPU overload sometimes. Cool. And then when you open that, this is what it's going to look like. It's going to be a Gradio app for those that are not familiar with. It's a very easy way to create sort of these GUIs with Python and allows you to do a lot of cool stuff like load up neural network models and so on and so forth. So this is what you'll see with the demo app. In the GitHub repo, you will also be able to have this be made, but there's also going to be ways that we can code it manually. And speaking of that, actually, I should have not. I knew why I didn't want to full screen this because I wanted to, there we go. So, does anybody have a good prompt for me for like a song idea? Real quick.
Sad song.
Sad song. Wait. Give me a... No, sad song is good. Okay, let's add on top of that while I figure out how to make this small again. Technical difficulties. Acid Fusion Jazz sad song. Okay, we're gonna put that in there. So you'll see this here. So it's hard to see, but we will. I had something there before, so I'm just gonna delete that. And then okay. So we're gonna write that down, and that's gonna just like be creating something behind the scenes while I go ahead and start to talk. So, acid, jazz. What was the other thing? Fusion jazz. Okay, fusion. I'll just throw it in there. Sad song. All right. Okay. So while that's happening in the background, we'll go back to the talk here. Where is the mouse? There. Okay, cool. Okay, sorry about that. So that's going to be happening in the background, and we'll be able to check it out at the end of the talk. And if you already have the web app on, you can start playing with it as well. So before I begin, I should probably talk a little bit about me. I'm actually, by training, a neuroscientist. I'm technically not a developer. I've met some developers that will maybe like, oh, you're not a developer. I've seen your code. But yeah, no, it's true. I'm not a developer. But I do code. And I think that's good enough for now. And so the research that I do is, I'm a neuroscientist, but there's many different types. I focus a lot on the sort of theoretical part of neuroscience. So how do people think? What is memory? What is space? What is context? And so the stuff that I've been focusing on lately in my research is how does space or context, like this conference room right now, influence what we remember? And so a really great way to study that is that it's not very easy to put people into the real world and scan their brains while they're walking, although that's becoming easier sooner rather than later. So instead, I create virtual reality experiences, and I have them explore, let them do fun games, and then I put them in a big scanner. It's called an MRI machine. And then I use machine learning to sort of understand what they're thinking and understand how their conceptualization of space influences what they remember and how they remember. But when I'm not thinking about brains all day, the only thing that actually keeps me sane is actually doing a little bit of filmmaking. So if there's anybody here that likes art and likes filmmaking, we should totally talk. I'm really into it. So I experiment with 3D, obviously from the virtual reality. I have experience with 3D modeling, so I like to do a little bit of CGI. And I'm also a bit of a futurist. So I also really, since the neuroscience and then the technology aspect, I've been thinking a lot about that recently. I think it's almost hard for any of us not to think about all that. Apple's going to come up with their Apple Vision Pro. Augmented reality is going to become very normal, potentially, in some way. And so there's a lot of ways that this technology is going to be able to access a lot of our physiological information. Some of you may already have smartwatches that already gather a lot of your heart rate and other things like that. What does that future look like? And what are the ethics of that? And should we be thinking a little bit more deeply about how that future will unfold? So that's what I'm interested in as well, in addition to all the stuff that we're going to be showing you today. So if you guys want to chat later in the future, I'm so down. Cool. So in today's talk, I'm going to introduce the topic of generative AI, more specifically for music. And then we're going to go through some of the steps that we need to generate this music, and then an overview of potential cases, and then at the end, a brief recap. So very simple structure. So generative AI refers to sort of artificial intelligence quite broadly. How many of you are in some ways familiar with AI, or for you, is it just like a weird term that people throws around? Okay, so who here, raise your hand, AI is just a weird term that people throw around and you're not really sure what it means? Oh, nobody. Okay, so you've all have some like experience. Okay, so then I don't have to go crazy about it. But in general, you know, AI is basically just a bunch of neural networks, and we'll get into some of that. And they can be used to create text. They can be used to create data. It can be used all sorts of things, but also sound. So in today's talk, we'll be going through sound. And obviously, you guys are hearing me. And right now, there are a bunch of there's a lot of energy that's compressing air, and it's compressing air, and it's entering your eardrums. And that that pressure is then converted into signals that your brain can understand. And over our entire lifetime, our experiences have allowed us to sort of parse those sounds and label them into words and language, and allows us to understand. And so a computer also needs a way to understand this information. And so a microphone might end up taking that information and converting it into digital bits. And so one way that can happen is by taking tiny snapshots of a sound wave, and those are called samples. And we also have amplitude. So in the case of like real sound waves, that's like how much air is, the compression of air. We can think that as the amplitude, and that's kind of like loudness. But these are important. These are two important features that are going to matter for how we interpret this data. So it's going to be samples and amplitude. So sound can be stored in many different ways. I mean, I know it's kind of like obvious, but there's something very important that will come out of this idea. The idea of representation. We can represent sound in many different ways. We can represent any type of data in many different ways. And there might be a loss of some information because of the way we transform it into a particular representation, but we might also gain something else, or we can infer another representation from it. So for example, you know, we have a waveform, we're all familiar with that, but we can also represent music in terms of a MIDI file format. Who here has done electronic music production in some way? Okay, so you guys all probably have played with MIDI controllers, right? There's velocity, there's a bunch of little features. All of that, you know, in some sequence over time with your fingers turns into sound. But that's still a representation of audio in some way. We have the spectrogram, a classic way you've all probably seen, which is like a picture that captures the frequency amplitude of an entire piece of music. And some of you are thinking, if there's generative art for images, can you make music from images of spectrograms? That feels like maybe you could, right? You just take all the music in the world, turn it into a spectrogram, feed it through the network, and then spit out another spectrogram, and then do reverse Fourier transforms and get that back into sound. Well, that's actually also been done, but that's not the talk for today. We're going to do something else, but it has been done, and it's actually really cool. So again, anything can be represented in so many different ways, and this is useful. Because when we think about neural networks or any of these sort of super complex systems, and this is actually also how I think about things with the brain. We think about in terms of representations, patterns. Can those patterns be encoded in some way that's understandable and then decoded back into some way that's understandable? So again, like I think it's important to talk about this as well. So there's a lot of things that we can do with this type of stuff. You know, we can be super creative with music. We can collaborate with someone and build something together, we can do things much faster. So for those of you who have done the music production, you know, sometimes you're like trying to figure out a melody, or like you're trying to do that beats, like some sort of drum beat, and you're like, oh man, this sucks. I wish I could just use a sample. And then you do use a sample. And then maybe you do some, you know, little extra transformations because you're like, it's gonna take me forever. So you gain a lot of stuff. And that doesn't mean that the music that you make or the music that you're DJing is worse. It's just you're doing a different method. It's still beautiful. It's still awesome. You're just taking advantage of the sort of infrastructure that technology has allowed. So yes, generative music is in that space. It makes things easier. It makes things more efficient. It's still growing. It's gonna get better. What I'll show you is pretty cool, but it's gonna get even better. And then accessibility, you know, that's a no-brainer. Like the more accessible these things become, the more accessible it becomes for people. And that doesn't mean someone that doesn't even know how to code would start being able to do this. And that's the part of the beauty. But then again, you know, we have like the classic cons, and like this is like a really classic debate, especially right now. The intellectual property. Who owns this? If I took you know, all of Taylor Swift's or any of this another famous artist, took all that music and put it into my neural network, fine-tuned it to just spit me out Taylor Swift music. Is that my music? I mean, I sort of coded the network, right? I mean, or maybe I didn't code it. I used a pre-trained one, but then I used it. I mean, I had the idea of putting the Taylor Swift music in that. Does that make it mine? I don't know. I honestly don't know. I think about this all the time, and I'm actually really curious into like what all of you guys think. It's a very important topic, and we're delving really, really, really deep into it, especially now as every country's trying to like figure out how to deal with this, and like, you know, yeah, I don't want to get into the United States world, but who knows what's going to happen. So, you know, in traditional software development, we will sort of, not me personally, but maybe you guys will, because I feel bad calling myself a developer because I feel shunned. But you know, you might code something that is specific. You know exactly what you want. Everything is discrete. It's to the point. But in like the sort of deep learning world, it's a little bit more vague. You sort of create some architecture. Generally, just like I'm thinking, you know, kind of broad. Like you have some architecture, and then you have some information that you want to like lay out in that architecture, and then after that you have an output, and then you have to figure out, okay, how do I want to evaluate the quality of this output? So it's less. There's a lot of creation involved, but it's more curatorial, and that's like a very more. It's a more management sort of position in the space of coding. And this is important because sometimes when we look at something like this, we're like, oh God, what the heck's going on? There are all these like nodes and connections and these things called weights. Well, like the easiest way that I like to describe it, and like the one that I like and personally I use really often, is that a deep network, okay, it's all a neural network. I think they just started calling it deep learning neural networks because they added an extra layer to one of these things. Okay, now it's deep. So as long as it has like 2 layers, I think, that's where it's deep. A deep, you can just call it a neural network, a net, machine learning, deep learning, whatever. It's all the same at this point, really. But I like to think about it in terms of a factory. You have, and this is going near like the black box sort of mentality that people have, but you can have some input, some material that goes into the factory, and you have all these factory workers. The thing about these factory workers, though, is that they have no training. They don't know how to do anything. But they all want to work together. And they just need some help learning how to do that. So they receive some material, and then at the end of the production of the factory, they're expected to come up with something. And you're there at the end, after it goes through the factory, and you're like, no, that's not good. Go back, try again. And they have no idea what they're doing. They've never done this before. And they come out with something new, and you're like, no, try again. And then they just keep doing this. This is one reason why it requires so much data, because these factory workers, they're untrained. They have no idea how to do anything. So you're teaching them to teach themselves and figure out a system. And so they organize in some way. And the way they organize is in the terms of the weights. How much distribution each node in the neural network has, that's how much, I guess, control one factory worker has, and that's how the distribution occurs. And I feel like that's like sort of the easiest way of thinking about it, and that's actually kind of like how it works. So in this case, we might have some bunch of data stream, like age, cholesterol level, chest pain. It could be discrete, it could be continuous, it depends on how you package it. You send it through some neural network, and then at the end, you want to predict whether it's heart disease. You have ground truth. You know, do you have some sort of correlational idea from all the people that have these features and have heart disease, and then you try to say, hey, okay, so this person with all these features has heart disease, and then you ask it, does it have heart disease? And they're like, no. Well, try again, that was wrong. And so then they rearrange, the factory workers start figuring out ways to how to combine that input data into something, a representation that makes sense. So there's many ways, there's many types of, I don't know how familiar you guys are, but there's like many terms in this space. So there's text-to-music generation. So that's just using some prompt, spits out some music melody. There's also things called like audio in-painting, which you might be familiar with from image in-painting, if anybody has played with Stable Diffusion or something like that. So in-painting is exactly what it sounds like. Think about it as a painting, in this case, 2 audio waveforms, and there's an empty part. And so you have to go in and paint that part in it. And so you're asking the neural network to do that for you. Outpainting, exactly what it sounds like. You have some canvas, aka some audio, and there's parts, you want to expand it. And so you go outside of the border, outpaint. And then there's things like style transfer, where you might have some song and you want to have it be represented in a new way that represents another type of style. Like say you have some country music, you don't like it, so you turn it into reggae because you like that more. But it still maintains some of the features that we appreciate from the original piece. So we'll be talking in this session about AudioCraft. Excuse me. Talking really makes my mouth dry. So AudioCraft is Meta's really new generative model, and it's kind of like a sort of all-in-one kind of model. You know, it provides a framework for music, for sound, for compression, for a bunch of stuff, and it's all in the same place. And it's really composed of 2 pre-trained models. Oh, this is an important term too. Who here is familiar with the term pre-trained? Okay, so not all of you. So pre-trained, remember those factory workers that I was talking about? So those factory workers, after they get trained, they can get, this is beautiful about these models. We can scale this. We can take that factory and make multiple copies of it, because now we know how the factory workers are trained, and then you send it off to a bunch of people. And so when someone receives a pre-trained model, they're receiving a model that's already been, the factory workers have already been trained. So there's 2 models in AudioCraft. There's Music Gen and Audio Gen. Music Gen is for creating music, and Audio Gen is for creating any type of audio based on the text prompt. So it's different from music because the features tend to be different. You know, there's a lot of co-correlation in music. A beat is repetitive, but a bird song might not repeat. So there's different types of sounds that require different networks of training. The advantage of using Music Gen, though, of AudioCraft, is that we don't have that intellectual property issue because they got permission. It's licensed music. So that makes it nice. The only disadvantage of that is that we can't ask for Lady Gaga or some other famous pop artist because, well, it wasn't in the training data. So how does it work? Okay. So I won't be able to go through everything because it would take a long time, but I think like the best way to describe it is a lot of these new models, I remember that idea of representation. So the trick in like being able to train really complex things like music. So music, we have samples, we have amplitude, right? 1 second can have thousands and thousands of samples. The more samples we have, the better, right? So say, for example, I'm taking a picture of a car from point A to point B. I take a picture, and I only take 1. The car's moving really fast. I get like a blurry image. I can kind of tell it's a car because there's some context. You know, I have some information. But if I took a picture every millisecond throughout the entire process, I get a lot more detail, and I know exactly where that car is going. But that's a lot of information. It's a lot of information. And these neural networks are powerful, and you can do a lot of stuff with GPUs, but sound, that's a lot of, with an image, it's still a lot, but you have pixels, you have RGB, it's kind of constrained. Sound, you have tons and tons and tons of samples. So how do you deal with that? So a lot of these types of models, whether it's for music or whatever, they focus, as I said, on finding an interesting and worthy representation. And so what they do is that they compress the audio. And so this uses actually encodec, which is another neural network model that Facebook made, which basically its job is to compress and decompress. So it takes some audio in thousands and thousands of samples and then compresses it into discrete chunks. That's I forget, I did the calculation, but I forget the orders of magnitude, but orders of magnitude less features. But it still manages to represent the gist, an idea of it enough, but just in a very compressed format. Those factory workers got organized in such a way where they know how to recreate things back just from that's the beautiful thing about compression here with neural networks. And actually, for me, when I was first learning about this, I think the most interesting thing that I learned is that you could use neural networks to compress information. So if you have, like, say, 100 layers, and each of those layers, let's say like an image, right? You have a 24 by 24 pixel image. You can compress that down into an even smaller image and then compress it back up. So if someone was given your neural network, the one that you used, they could send you a tiny image that's like maybe like 0.00001 of a megabyte, send it to you via email, and then you have the same neural network that they use to compress it. You can compress it back. That to me was like blew my mind, because I was like, oh wait, I still use JPEGs and PNGs. The only problem is that these models do take up space too, so you have to have that locally available in your computer. So it's not like the perfect system. But anyways, back to the music. So what happens here is that they're able to compress it into this sort of non-audio space representation. And then they're able to decompress it back, but we do all the math and all the fun stuff in that discrete space, in that more manageable representation. And you can do a lot of things with it. You can condition it with text. So, and how do you do that? So when you're training, you have audio, and they probably went on Amazon MTurk or something and had people describe these, or like it was a data set where you have the audio and you have a description for the audio. And you send both into the network. And what happens is that those workers start to associate what some vector representation of text, how it's associated with some vector representation of music. And so that's how you're able to then use prompts to then generate music, because that text information is now associated with this more abstract music representation. And then you can convert it back. So now let's jump into the code. So it's, the beautiful thing about these things is that they're pre-trained, so there's not much we have to do. So the first thing is that we have to initialize the generator by choosing the model. And in this case, for Autocraft, it's like small, medium, or large. We then load the model. And then if it's loaded, and that's that if statement there, we set all the parameters that we need. These include like the duration, how many seconds we want for the audio to be created, the temperature. So here, a higher temperature means that the model is allowed to be a little bit more creative, so it's less predictable. And then we can generate music with the prompt. So in this case, it can output, because of the training, a waveform and the sample rate. And then we can reconstruct it back into sound from there. And so, yeah, I mean, honestly, that's basically it. And then, of course, because these models do take up a lot of internal space, and if you don't have a GPU and it's just your CPU, you probably want to unload it. So that's what that last line is. We delete the model from memory. Oh, that wasn't supposed to play immediately, but so can we raise the volume up for that? So what happens when we use some interesting text prompts? So what would, I was supposed to reveal it. It wasn't supposed to happen like that. It was supposed to be a reveal. But so for the music dance party, how do I, oh man, the mouse, there it is. Okay, so you probably heard it already. What would music for a dance party at the bottom of the ocean sound like? And this is the kind of stuff you can just come up with random stuff, because all these words, they have some sort of representation in that music space that can turn into something. So you can do kind of whatever you want. So that's the one you heard, probably. Kind of does have like that Caribbean vibe a little bit, you know, a little bit. I could dance to this. Who here could dance to this? Oh wow, that's sad. I appreciate y'all that said yes. Okay, the sound of a dream about time travel. What would that sound like? Gives me a little bit of time travel vibes. And of course, something that we can probably all, oh, nope, relate with. Oh, not that one. Oh, God. Yeah. Yeah, live demos. But I do want you guys to hear that, so I'm going to go back. All right, doesn't matter. I guess now I know that the first one is the one that's going to play automatically. Okay, so another thing that we can do, so we have text-conditional generation. So as I said, that's when you use a prompt. The prompt gets some representation in textual space that's associated with music. But we can also use melody conditional. So what that means is that we can condition the model with a melody. So that's, the way that they did it, I think that they just convert, you have some melody and then you, another cool thing about the way that they did it. So instead of using a spectrogram, which has tons of frequency information, they used a chromogram, which actually compressed the information from a spectrogram and forced it into an octave. And that's actually a really clever way to keep all the musical information. Obviously, you lose a lot of information, but it gets compressed, and so you have to deal with less features. Because a spectrogram, that means that those factory workers are going to have to learn a lot of continuous information across frequency space. And that's not super great. It's better to just kind of force them to have like a specified key. Anyways, so melody conditional generation is that we can give it some audio file and then ask it to do something with it. So now it has this musical file in its representational space as context, and then it's able to then generate something from it. And then just like before here, it's very similar. We can set whether we want the model to be small. That's where the model parameter goes here. And then we check if the model is loaded, and we choose the parameters. Again, temperatures for more creativity. And then just so we have like a visual of the progress bar. And then we generate. We get sample rate, wave, and then we have to delete the model. It's as simple as this. And like that's another thing that I want you to take away from this is that now that there's, thankfully, the open source community, these models are becoming easily available, and all we have to do is get creative with them. Everybody recognizes that, right? So what if we took that, so now we're conditioning on that melody, and then we added a prompt to go with it. So in this case, an emotional and progressive heavy metal song. What would that sound like? Not bad. It's kind of scary how good it's getting. So there's going to be audio in the next one. Another theme everybody might recognize. Oh, no audio? It's not playing? Oh. Now I get to choose. Oh, this could have been my fault from the presentation thing. Now this one's gonna impress all of you. This is actually pretty good. So, a cheerful country song with acoustic guitars. Not bad, right? And for this next thing, so this is again text-conditional music. This is kind of like what we said. So this is just reimagining some prompts. So if we can do styles here. It's again just very similar to what I said before, and the architecture again of the code is very similar. We just load it, and then we have to set some parameters, and then we generate. And of course, again, always important to delete the model. You have no idea how often that's going to be a problem. If you don't delete this, you're going to get a bunch of memory errors, your computer's going to stop working, you're going to start wanting to throw yourself out the window, like I did multiple times. So remember to delete these models. So another thing that I thought would be cool if I looked at some of the top Spotify artists in Lithuania, and let's see if we could like get a little creative with this. So among the top 5, there was Jessica Shy. I'm not sure. I guess I don't know how to. Okay, and then please nod for giving me comfort. And then ProFlame. Is that also right? Okay. Which actually have really, really, really good music. So I took the one of these tracks, Business, by ProFlame, and this is what it sounds like. Let me see. I wish I could click on it on the other side. So when we do text-conditional music continuation, we can do things like sort of what would happen if we took that audio piece as context and added a prompt to change it after a certain time. So groovy, right? Man, this makes me so sad because I produce music sometimes and I'm like, damn, that's good. So what about Jessica? So this is Alpha Pink. Alpha Pink? Okay. Alpha Pink. Oh, wow, that is so off. I got it so bad. Okay, I'm gonna remember that. So as I said, there's like a lot of room for creativity here. And at this point, like the only person you can blame is yourself. You could just think harder. There's so much we can do. So here is the sample. So if we did upbeat tropical merengue, so some of you already anticipating what's going to happen. Kind of turned into like a reggaeton kind of vibe. Again, this also depends on the training data. So the training data is going to have a huge influence. That's why fine-tuning is important. So what about lively beach dance reggae with electric bass, funky guitar, and groovy percussion? What could it possibly do wrong? It's interesting. I could still groove to that. And I particularly like this one, especially because of the saxophone. So soul funk with heavy percussion, trumpet, and saxophone. Honestly, you could just start throwing keywords in there and see what happens. That saxophone hits hard. Especially because I had that reverb, so it's like a producer was behind that, right? So this is another example. So this is, again, another really cool thing is that when the people are making these models, there's so many ways you can combine them. So you can do a lot of combinatorics here. So this is Melody Conditional Music Generation and continuation. So this is... So this is just humming, well, whistling. So now we're using that as context to continue, but we're also using that to do some basically a sort of style transfer within it. So energetic drum and bass song. Who wants to go to a rave? They're learning. Ooh. You know, it's not that bad. I could definitely hear the drum and bass though. Like you could hear like there's like the little breakbeat happening there. So I definitely got some of those things right. So there we go. So yeah, so there's tons of things you can do. I mean, for how many, okay, actually I'm really curious. Who here has not used ChatGPT? Wow. You will survive the apocalypse. So some of us may have already started using this for helping us with ideas, with sort of like, okay, I have some rough idea about something, throw it in there. So this type of AI, like for music, can also help us with songwriting assistance. I mean, I can already imagine like making some samples and then cutting them in my way, or then maybe like maybe using keywords and then finding out some weird space in that music space within the model that's mine. And then nobody's going to use this kind of keywords. Nobody's going to, or maybe I'll fine tune it. And then I can start using those samples that I created and then repurposing them and then transform them even further, because that's what I usually do. So again, personalized music creation. Fun things like interactive storytelling. You could have someone having a talk and then there's music in real time playing behind them that in some way is a backing track to the words. At that point, you'd probably have to like do a little bit of fine tuning to the model, so it's not just like if you say rock and you're talking about like an actual rock, it doesn't start playing, you know, something crazy. You want people to be zen. And then, of course, there's music therapy, and this also goes back to accessibility. So a lot of this beautiful technology makes it much, much easier for people to be creative and not really have to worry about being able to be physically able to do something or not. So to recap, we've done a little bit of all the things that we discussed. So we've done a little bit of text-to-music generation, so straight up just a prompt. We did a little bit of outpainting, which was like the music continuation. We've also done a little bit of style transfer, including using the melody and the text conditioning, and we didn't do audio inpainting, but I think like this is probably enough to get you guys going. Again, the things are in the repo. And then lastly, if you guys kind of like this sort of approach of like giving power to the people, finding really easy and cool ways to take any language models or music or things like stable diffusion and being creative with them. So my brother, Serge, who was actually a speaker here last year, and another one of my brothers, we're working on a book called DIY AI, who are making this kind of stuff super accessible for everybody. So if you want to keep up with that, just let me know. And now I will be happy to, oh, one last thing before we open it for questions. Can I just take a selfie with you guys? Is that cool? That works? All right. I usually do this. And music generative AI. Okay, that was just me. Anyways, I appreciate your attention. Thanks very much. What was that? Oh, the sad song. I completely forgot. Of course. And that is going to be right there. Okay, so now, actually, so I called it audience test. Can I get the audio for that? All right. Let's see. Acid jazz, funk, sad music. What was it? It could be sadder, but it was kind of there, you know. We were waiting for the bridge. At that point, it gets sad. Yeah, so any questions? Is there time for questions?
Yeah, it's definitely a time for questions. So if you have any questions, so please just raise your hands. I will walk towards you with microphone that other viewers could hear your question. So do you have any questions right now?
We can talk about things like the ethics of this stuff, because that's always it's a hot topic. Oh, over there we have someone in the back. What's music? Sound. What's
Andrew?
sound? Oh, sorry.
Thank you so much for so nice talk. Do you know that before ChatGPT has been released, AWS Cloud just created some kind of deep composer?
Yeah.
Did you try it?
No, I did not try it.
Okay.
Yeah, but so there's a lot of models out there, and it does take a while to sort of pick and choose, right? Because you have to figure it out, test the model, and then sometimes these models require a GPU, and if you're just on a laptop, then you can't really do it. So then you have to set up a server with GPUs, or you have to buy a desktop with a GPU. So I haven't tried it, but I've heard good things.
Yeah, but just interesting things that deep composer using reinforcement learning based on reward system.
Ooh, yeah. RL models tend to be really, really good.
Thank you very much for your question. While I'm walking towards you, I have a question. Do we have any other questions? Since we have a few minutes. Oh, okay.
Hello, and thank you for the presentation. I'm interested, is it possible for a user like us to pre-train it with another set of music that we like instead of using this pre-trained model?
Yeah, you can fine-tune. So I think that's the sort of culture now. Is one of these open source models are released, and then you're able to fine-tune it. You wouldn't want to train it. You wouldn't want to reset the weights and train it yourself, because you would need a lot of energy and power and compute to do that. So I would take advantage of the pre-trained model and then fine-tune on top of that. But yes, an everyday person can do that. How easy it is in terms of compute, definitely easier. But sometimes, for example, for Stable Diffusion, fine-tuning can take a bit, depending on the type too. If it's textual version, well, that doesn't matter. But the point is, yes. Yeah.
And we have a last question right here.
Thank you so much, Rolando. I'm curious, it's a two-parter. Do you have a favorite piece of music that you made with this technology that you're off the top of your head?
Oh, no, not yet. I don't have it on this computer, but you can imagine that I have folders at this point of just hundreds of these, and sometimes you make it and there's one that's oh, this one's good, and then other times it's because we're traveling in this weird sort of non-exact compressed audio space trying to find something beautiful. So no, but maybe that's a good project that I should continue.
Well, yeah, kind of to that point, because and it kind of entered my mind when you very briefly mentioned ethics. Do you see a way of going from here to, say, publishing some of this stuff? And if would it be something that you'd consider, or is that kind of already on that sort of blurry ethics line?
Oh, I love that question, because it's difficult to answer. And every time that I talk about this, I don't think I come up with a better answer ever. No, it's fine. No, this is why I love the question. It's difficult because every country has different things, but it's kind of similar. There's this idea of fair use. So if you're able to transform something enough from its original form, then you had enough license in it in terms of creativity that it's now yours. I think that we should still work under that. I think that that's important. If we try to strangle some of the stuff that we create with a lot of these models, then we're going to stagnate. But I think that we do have to set some principles. It's really hard though, because the music industry is it's really full with issues, and issues that don't really belong at fault to the composers or musicians. It comes down to the labels. Even the whole Spotify thing, right? Can I talk about this? The record labels were asking a lot from Spotify, which is why artist didn't get a lot of money. And so then Spotify got blamed because, oh, we're exploiting the artist. Well, no, it was like they had to make a deal with like the record label that wasn't allowing them to do a lot of stuff. This may be false, so don't fact check. I don't know everything. So yeah, to answer your point, I think that if there's enough transformation to a created piece, then I think it's okay. But I may change my mind tomorrow.